Welcome back to Advent of Code Day 5 Print Queue. There is a lot of reading on this day, and I'm just going to put these on the screen for you to read if you want to. Here's the puzzle input. It's split up into two parts. Here is more of the problem, here is more, and here is more. In short, we are updating pages of some manual and a printer or something. Certain pages can't be updated before other pages. And so down here on the input, we have the proposed updates. And in the first half, we have the ordering rules. For any given line, this says 29 can come before 13, but 13 cannot come before 29. And so if we analyze all of these rules, and then we look at a proposed update, if we break any of the rules above, then that update is invalid. What we need to do is identify all of the valid rules, and then for every valid rule, we take the middle number and add up all of those middle numbers. It's just a kind of a magic answer. There's nothing really important about it. For my solution to part 1, I'm going to keep it pretty high level. I'm not going to go into too much detail because it's going to take too long. Start off, we're going to split the input into its relevant parts. The first half is the rules input, and then the second half is the proposed updates. And for the string that defines the ordering rules, we'll split those up by the pipe characters, and we get something that looks like this. The next thing is to pass this 2D array of strings into this function to build dependencies from the ordering rules. This array is an ordering rule, and we want to combine them. When we return this and print it, this object looks like this. 61 blocks 13, 53, and 29. And when we look at our test input and we find 61, yes, it does indeed block 13, 53, and 29. The first thing we do in this function is turn our input data into nicely usable array of strings. This information here turns into this array of strings here. We are then left with an array of updates. To validate an update, it's going to be a lot easier to check if the update is invalid. And what we can do is start with the number farthest on the right and check if this number blocks another number and we find that other number anywhere else in the update previous to it, then that update is invalid. Let me walk you through that. If we look at the last number, 47, we can check our rules and see 47 blocks number 13, blocks number 61, and blocks 29. So if we see 13, 61, or 29 anywhere in this update, then it's invalid. And so walking right to left, the first one we find is 29, and it's invalid. And once we find that an update is valid, we add the middle number to the magic answer, and I get 143, which is what we want from the test input. Here we have the real input. Let's run this. 6 milliseconds to get 5,391. And we'll submit that, and we get it. Boom. And now for part 2, what we have to do is take all of the invalid updates and then reorder them to be valid. Then take the magic numbers from all of the fixed updates and add them up to get the magic answer like before. For the solution, we don't really need to change much. We're just going to find the ones that are not valid now. Then we reorder the updates and count the middle value. In order to reorder the updates, we're going to steal the logic from earlier to check if it's invalid. With one major difference, we're still looping right to left, but for J, we're going to loop from 0 and go left to right. And the main idea here is let's find this value 47, then let's go left to right and find the first value that's invalid, which would be 13. Then we'll take that index and we'll swap those values. This would end up looking like this. If we keep running that algorithm, eventually we'll find 0 invalid orderings and we'll have a valid update. The actual code looks like this, looping through the indices right to left, looping through the other indices left to right. If we find a value that breaks the rules, save that index. If we find a bad index, swap the values. If we don't ever find a bad index, we will break. When we run this program on the test input, we get 123, which is exactly what we're looking for. Now when we point to the real input, we get an answer of 6,142, and that took 15.9 milliseconds, which might be slow, and we'll go ahead and submit the answer for another gold star. My advent calendar now looks like this. Not sure what it is still. I'm a little disappointed that I didn't actually use a queue data structure. I'm sure that there's some other fundamental approach to this problem that I could have used. So if you solve this in a different way, let me know in the comments below. If you're enjoying Advent of Code, make sure to subscribe for more tomorrow.